We're going to talk about the transformation of graphs. And so the first thing we have to do is look at the parent function. So here's e to the x. And the important thing to know about e to the x is it's got the horizontal asymptote at y equals 0. And it's got the key point here at 0, 1. Those two things will be important. For each graph, it's important to know some key features. When we slide it around, we can tell where things have gone. So let's look at a couple of others before we do an actual problem. Here's e to the negative x. It still has the horizontal asymptote at y equals 0. But now notice, because I flipped the graph, the key point has moved to 0, negative 1. And that will be important if we're dealing with a negative e to the x problem, because that's the point that you want to use. Here's ln x. ln x has a big shift for us, because now instead of a horizontal, it's got a vertical asymptote. And the vertical asymptote is at x equals 0. And our key point is here, now at 1, 0. And so then if I flip this using the negative ln of x, it still has the vertical asymptote at x equals 0. But unlike negative e to the x, because we're flipping over the x-axis, a point on the x-axis doesn't move. So its key point is exactly the same. All right, and so both of those things will be important on whichever graph that we're going to translate. So let's take a look at an actual problem. I have the function down so you'll see how we end up getting to it. So there's the actual answer. But so if I'm going to do it by steps, the first thing I would do is decide, is this a log function or is this an exponential? And the way I tell is, what's the asymptote? The asymptote is vertical, so vertical is a log function. So there it gets me the log. The second piece is positive or negative, and since this is moving downwards, then this is going to be a negative function. So there's my negative ln. So we have the direction going downward as we go from left to right. And so now I have to figure out, how do I get those numbers inside? Well, those are the shifts. So I can't really tell just by looking at it. I know my key point is 1, 0, but where the heck is 1, 0? I can't tell that. But what I can do is I can tell where that asymptote went, because I can see the new one, and I know the old one started at 0. So let's just see how far it shifted. And so we'll just count, and that moved left 1, 2, 3 spaces. And remember, the left and right happens on the inside of the function, and it happens opposite of sign. So since left is normally negative, that's going to be x plus 3. To find the one on the outside, or to find the number on the outside, what I want to do is I first start at the key point. So the key point is at 1, 0. And I know this whole function's been shifted over left 3 spaces. So that means the key point must be shifted left 3 spaces. So let's go 1, 2, 3. And there's no point there. So that means the key point must have went somewhere else. So it must be below us here. So we'll move down till we hit the graph. And then if I go over, notice the new key point on the graph is at negative 2. So that means this curve was shifted 3 units to the left and 2 units down, and that's how I get the final function, negative ln x plus 3 minus 2. All right, let's do the same thing with an exponential function. This time I know it's a exponential 1 because it's horizontal, so that gives me the exponential. Get the horizontal asymptote. I know it's positive because this graph is moving up. And so then the first thing I need to do is find the shift in the asymptote. So in this case, we're talking about going up. So this has gone up 1, 2, 3, 4, 5 spaces. So And up and down is the outside number, so there you see the plus 5. So now how do I find how far it shifted left and right? So remember, that's the key point. So the original key point for a positive exponential was at 0, 1. So I know the graph's gone 5 up, so let's shift 5 up. 1, 2, 3, 4, 5 up. It's not on the graph, so the key point has to be to the right. And if I notice, that happens at x equals 4. So it must have been shifted right 4. And so then there's you get the function. It's positive, exponential. The right 4 comes from the exponent. Notice it's negative 4. And the up 5 comes from the outside. And that's it. You can do that analysis on any of the functions.